Hi, welcome back to the channel. So in this video, we will see a very important concept of the next in the electronics, that is rectifiers. So we should understand what is rectifiers and what are the definitions of rectifiers and what are the types of rectifiers. First, we will understand what is a definition of rectifiers, right? So rectifiers are electronic circuits. Rectifiers are the electronic circuits which consisting of diodes and which are able to convert alternate current into a direct current. What is the meaning of alternate current? Which is always like this. We will call this type of current as alternate current. It is having a fluctuation. We can measure this with respect to 0 to 360, right? So it is with respect to time. It is varying. So that variation is represented here with the help of sine wave. So this is called as alternate current, right? Then what is the meaning of direct current? Means it is just like this. So we are having this type of current. Suppose current is represented by here. So this current I can write it as IAC. So if it is a direct current, I will write it as DC. What is happening here with respect to time? Look at this. This current is going to be what? Constant throughout whatever the time. But here it is what? The current is varying, right? So if I use these rectifiers, the varying current or the voltage is converting into a constant current or the voltage, right? So here that is called as AC to DC, and here this DC is not just DC, we will call it as pulsating DC. The meaning of that is it is not the purest form, it is the impure form of DC, right? So here whatever the DC you are getting, so you are not going to get like exactly this. So you may get like this, right? So this is pulsating DC, we will call it. So the definition of rectifiers is electronic circuits which consisting of a diode which will convert AC to pulsating DC. So this is the first concept. So I want to convert this to this and like this. What type of rectifiers we will use? So here that concept we will take here under the heading of the types of rectifiers. So in the types of rectifiers we should see now the first one. First one is half wave rectifier that I have written there, right? Then the second one is full wave rectifier, and in that the case is center tap, and the third one is bridge rectifier. So here first one I will take the half wave rectifier. Half wave rectifier, right? In short form we have written as HWR. It is half wave rectifier. So we'll see in detail with respect to this half wave rectifier, right? Later we can see what is full wave rectifier, center tap, bridge rectifier, that is full wave, right? So we'll see the second and third later. So we'll see only the first one, that is half wave rectifier. So first we should draw how exactly this circuit diagram look like for the half wave rectifier, right? So here we know that what is the input? The input is AC. So I will write it as AC supply is the input, right? So this is the input. So you can, if you want, you can write like this. It is AC supply which is varying, right? Now for this we are going to convert AC to DC. So here we should transform AC to DC. So what type of devices will come into the picture now? Transformers. So now the transformers going to be written like this. If I write like this type of transformer, we will call it as step down transformer, step down transformer. Look at the number of turns. Here we will call it as N1. Here we will call it as N1, N2. It is primary section. It is secondary section. Primary section means here. Secondary section means here. And this ratio we will write as N1 and this is N2. N1 stands for number of turns. 1, 2, 3, 4, 5, 6, 7 like this in the primary. N2 means number of turns in the secondary. We will always mention this with the help of N1 by N2 is equals to like 4 divided by 2 if it is 4 at the primary, 2 at the secondary. So what is the value of this? It is 2. So N1 by N2 ratio is 2. Right? Like this we can analyze this transformer. So basically what we have written is step down in this case. You can write it as step up also. Right? So I will write it as step down transformer. Suppose you want to convert the voltage, high level voltage, AC, how many volts you are having? AC 240 volts. So I want to reduce it to the lower voltages. At that time we should use a step down transformer. Assume that now I want to use the step up transformer. At that time how this transformer changes? So it is initially you will be having like this. It is primary and it is secondary. Primary is having less turns and secondary is having more turns. Right? So that is a step up. So here, so at the beginning we will consider a step down. Later we will see what is step up. Okay. So the meaning of this is it is reducing the voltage from 240 volts to the lower voltages. Assume that I want to convert it into 5 volts. You can go for the step down. For that you should take the ratios properly so that it is going to reduce to 5 volts, right? Because in the home, assume that the main supply is coming to 40 volts. But what is the TV is taking? What is the mobile is taking? What is the mixer is taking? What is washing machine is taking? What is refrigerator is taking? That all the things you should know, right? So this is the transformer job. Then after that, we should add a rectifying element. That rectifying element is called as here diode. So this diode is called as a rectifying element. So it is rectifying element diode. We know that in the previous class it is P and N junction. P is consisting of plus and N is consisting of minus, right? So it is PN junction diode. So we have done as plus and minus, right? Then after that, here this extension you can take, right? This extension you can take, and here we should write a resistance. The resistance is going to be like this, and this resistance I will name it as a load resistance, right? So after that I am going to take here what is the voltage which is across this load resistance. So what is the voltage across the load resistance? We can write it as VL, or we can write this as V output. V output in this case, what we can write it as VDC. What is our job? Our main job is to convert AC to DC. What is here? AC, and what is here? It is DC. So that's why we have written this as VDC. It is nothing but V output. It is nothing but load voltage. All the loads we can measure with respect to your output. So we have taken it as a load resistance and the load voltage. So this is the circuit diagram. Just the circuit diagram. How the half wave rectifier look like. And look at the direction of the current. Diode is in this direction. So we can write it as the current, which is, we can write it as either with a small letter or capital letter. Suppose if I write here the current I, so I can write the current I, which is flowing through this diode D. So I will mention this diode as D, right? So this is the circuit diagram. So after this circuit diagram, now we can write the next thing. What exactly which is happening? We can call it as working operation or principle, whatever you can call it as working. So what we should write now? So here, so input. Look at the input. How it is? It is like this. So suppose if I give out of this complete sine wave, so I will mention this one as, now just look at the input how it is. Input is like this, the sine wave is going. So out of this, if only the positive half cycle is going to the input. So I will consider this as case number 1. If the case number 1, the input what you are giving is, that is only the positive half cycle, means through this the positive half cycle is going. So at that time what is happening is, just look at now, this transformer I will write as it is here, and this is like this. So now I should see what is going to happen with respect to this diode. Now here, if it is positive, this transformer terminals, here it is plus and minus, here it becomes plus and minus. It becomes plus because of this plus. So here the diode becomes what? The diode becomes a short circuit, so that diode will start conducting. So I will write this as diode D is on, and all the current or the voltage you can take at the load resistance, that is, you can write it as RL. What is the current which is flowing through this? I will mention this as current ID, because diode D is on. And here, what is the voltage? You can take it as V output. It is nothing but VDC, right? Or you can write it as VL, right? The current conduction is on, and you are going to get what type of output? So if this is the input, what type of output you are getting? You are going to get the same kind of output. So this is my output, which is VDC, if it is a positive half cycle, right? So case number 2. So I will take the case number 2. What is case number 2 is, I am going to give the input now. After this, I am going to give the input as the negative half cycle. This is the next part. Like positive is over now. Now I am giving the negative. Only this portion I am giving to this one, so that this transformer, what you are going to have, this transformer, what you are going to have, now check what is going to happen. So if it is negative, this is negative and this is positive, this is negative and this is positive. Look at this. If it is negative, look at the diode status. What is you are having P side and it is N side. P side majority is plus, right? So it is plus and it is minus. So it is plus, it is minus. What is plus and minus combination? It is diode acts as reverse biasing. Diode acts as reverse biasing means it becomes what type of circuit? Open circuit. Hence, we'll make this as an open circuit. So in this case, you can observe when it is positive, here positive and negative is there. Positive and positive, it is forward biasing, then diode acts as short circuit. Here it is minus and plus, so the diode acts as the open circuit, and here we can draw like this. So the current ID is open, means what is the value of that? 0. So it is through RL. What is the voltage is V output. V output is equals to VDC, and the value of that is 0, right? So for the negative cycle, how we can write your output? I can write the output for the negative cycle like this. So it is VDC, right? So for the VDC, how we can write? You can write, I am not getting anything here for this part, right? So for positive cycle I am getting here, and for negative cycle I am not getting anything. So here, if I pass the complete sine wave like this, my diode is going to be conducted, that is on. Diode D is on, or D1 is on. Here the diode D is off. Current is going to conduct through the diode only for half cycle. Here the diode is not conducting, right? Conducting for the another half cycle, right? That's why it is called as half wave. The diode is conducting only for the half wave. Means if I send the input like this, I am going to get the output like only this much for VDC. For the next part, what is going to happen? Here for this part, the diode is off. For this part, diode is on, right? So this is for the complete cycle. This is the diagram, right? So how we can write this diagram? I hope you understood this diagram, circuit diagram and the working operation. Now how to draw this circuit? How to draw the waveforms. So how to draw the waveforms we'll see now. Once you understood this halfway rectifier, then the next full wave rectifier becomes very easy for you, so that go through halfway rectifier carefully. So if we draw the waveforms, then it is going to be clear for you with respect to here whatever you have drawn. So now I'll take the help of this input. How the input is? So for that I will take here T 0. Input is, I will take 2 cycles, positive, negative, positive, negative. So here I will mark like this. Right, this is the input. What is input? Input is AC, right? Then after that, so here I am going to see what is going to happen when you send the positive side, right? When you send the positive side, what type of output you are getting? You are getting the diode D is on, and you are getting the output like this, right? When you send the negative one, what is happening? The diode is off, and here you can write diode is off. You are not getting anything. Current is 0 because it is open circuit. So again, if it is positive, diode conducts. If it is negative, diode doesn't conduct. So it is on and it is off. So what is this? This I can call it as V output, or we can call it as VDC. Right? So it is positive. Right? So this is the output voltage for the half-wave rectifier. Look at this. For entire cycle, one complete cycle, you are getting only for the half cycle, and this half cycle is 0. So that's why it is called as half-wave rectifier. Right? Next, after this, now the question is whether what we told at the beginning, we told that what is the job of rectifier? The job of rectifier is it should convert AC to DC. Now check whether it is converted AC. How you have written AC? AC is like this. How you have written DC? DC is like this. Now whether we are getting the output like this, check here. No, we are not getting. So that's why we are telling that it is impure form. It is pulsating. But still, now we can improve this circuit with the help of a circuit called as half-wave rectifier. Half-wave rectifier with capacitor filter. We will call it as half-wave rectifier with capacitor filter. So now I will introduce this as capacitor filter, so that we are going to improve that AC to DC. So it is half-wave rectifier with capacitor filter, so that we'll see what is the kind of output we are going to get at the end. Whether we get like this, if we are getting like this, that is best, right? So for that, how your circuit arrangement is. So your circuit arrangements changes like this. So only one change. If it is a capacitor, so we should take the capacitor. Where you are going to take the capacitor? I will take the capacitor here, and this diode is in parallel. So it is RL. This is capacitor C, and we are going to take the output here, V output, which is nothing but what? VDC or VL, we can write it. Now this parallel combination of R and C, we call this as RC filter or capacitor filter. So if I introduce this capacitor, then there is a chance that there is an improvement in the waveform, so that we can convert AC to DC. So what exactly happening now? So what exactly happening is, so here for this we should see the positive half cycle and the negative half cycle thoroughly. Suppose now, see here, we are taking this positive half cycle, and here what is the type of waveform you got? Like this, right? And here negative half cycle, we are not getting anything. right? So assume that your input is start increasing from this point to this point. I will call it as something like A, right? So when it is increasing from this point to this point means it is increasing, right? When we input increases, so that what is going to happen, the diode becomes forward biased and the capacitor, what? Capacitor will start charges. Capacitor starting charges because of the diode conducts and it charges to the peak value. So that I am going to get here at the output as here I will draw the diagram and I will show you. So this capacitor, how it is going to charge us, I am going to take here this same, but this peak value I will pick, which is A. I will mention this as A. Capacitor, this is capacitor which is charging. Right? Now, after this point A, you can observe. After this point A, what is happening? Input is falling. Input is decreasing. Right? It is going in a negative direction. So, from here only it is decreasing. Not from here only. So, now, what we should do is, it is decreasing up to where? Up to here. Right? So, but here also what is there? Diode is not conducting. Now, this is going up to this point. So, up to this point. So, the capacitor, when the input falls below this input voltage, when the input voltage, it falls below this from this point to the next, you can call it as something like A and this is something like this. When it becomes below this input voltage, this diode becomes a reverse biased and this capacitor, what is going to happen is the capacitor discharges from this peak value which is already attained. So how to discharge? Discharging is happening like this. It is increased and reached to the peak. Later it is going to be decreased and it is going to be at this position. So I will mention this point as B. Then after that, what is happening with respect to the input? So I will write it as B. B to C, what is happening? Again it is input is increasing. When the input is increasing, this capacitor C, this diode D becomes forward biased and the capacitor C again charges. So that it is increases up to C. Then after C, what is happening? Falling or decreasing. So that it is going to be again like this. Right? So now how this waveform is going to be is, it is like charging, discharging, charging, discharging. So I will name this as charging, I will name this as discharging. Right? Now you can observe, we have initially written this is AC and this is DC. Now whether we are getting this type of signal? No. But what type of signal we are getting? We are getting this type of information or the signal or the DC output. Now whether this constant and this obviously is not equal, but we are getting a better results compared to previous. If we use what type of condition? If we use the RC filter because of the charging and discharging, right? So that is the advantage of using RC filter compared to a normal half-wave rectifier, so that you are going to reach towards DC voltage, that is VDC or V output, but still it is not a perfect one. So because of this huge discharging is there, so that we can't tell it is more reliable. Hence we are going to the next one. What is the next one is called as? So the next one is called as, so that is called as, it is the next type of rectifier, that is called as full wave rectifier. So in the full wave rectifier we will see in the next class what is the circuit diagram and how exactly the operation is going to be and how many diodes is consisting of and how the waveforms are and what is going to happen if I use a capacitor filter, right? So that we will see in the next class. Thank you. Stay tuned this channel. Click on the bell icon for latest notifications. Thank you.